Hello, everyone. Welcome. Man, I love seeing those numbers just flying in. Everybody's joining us. Thank you. Thank you for being here with us. We'll give people a few seconds to join in, get their lunch situated on your desk, and we'll start in just a minute. All right. I think a few people still in the waiting room, so we're gonna let them come on in. While we're doing that, though, we always love capturing um, where you are calling in from or dialing in from. Not only the company you might work for, but it's also always fun to see where you are in the world. So if you can in chat, drop it in and let us know what organization you represent and what city or part of the world you're joining us from. Love to see it. All right, I'm not seeing the chat. So hang on, let me just pull it up. Oh my gosh. Ohio, go Cubs. Great. We like that spirit. Hub International, Wintrust. Bosch, great. Chicago Public Library, CIBC. Okay, I was in Canada. Boy, did I see that logo everywhere. Samsung, welcome. North Carolina, Albuquerque, Houston. This is so fun. Orlando, Florida. I have a son there who works for Disney. Give a shout out to those guys. Samsung, HCSC, hello and welcome. RR Donnelly. So more from Florida, Des Moines, Iowa. Hey, I'm from Sioux City. CIBC Hub, Walgreens, Northern Trust. Shout out to you guys, the Housing Authority. This is great. You guys, thank you so much for sharing this. It makes this so much more fun, kind of having a sense of where everybody is dialing in from and what part of the country or the world that you're in. So thank you so much from City Hall in Chicago. I love it. Morningstar. Special shout out to Morningstar and Wintrust. They are two organizations that have recently joined our partnership, so we're especially glad to see you. So wonderful. Thank you. Let's get on with it. I am KK Nielsen Cleland. I am at DePaul University here in Chicago, and I work on the corporate and strategic partnership team. And it is my pleasure and honor to welcome everyone to today's session featuring Dr. Bamshad Mobasher. A little bit of housekeeping, just because we like to make sure everyone's well informed and we set some expectations. We're on Zoom, but you'll notice that we did record it. We've been working with Bamshad and the AI Institute all year, and we've been recording these and posting our sessions. I think this is our sixth one, Bamshad. And so we will post this later for anyone to go back to and rewatch, and if that's helpful. So note that we will send a follow-up with the slide decks so that if you're interested in having those as well, we want to make sure you have access to that. So that's the exciting housekeeping. We encourage chatting. We encourage conversation, asking questions. You can send questions directly to me, or you can send them to the larger group, and happy to have your participation, and a special shout out to any DePaul alumni joining us from around the world. We've been doing these DePaul Speaker Series for the last 5 or 6 years. And we're always thrilled when we have DePaul friends and people who know about our institution. Some of you may not. And rather than going into a ton of detail about DePaul specifically, there's some things, though, I really want to make sure everyone has a chance to know. And that one of the things that we think makes DePaul so unique and different is how we are connected to companies and industries and the larger communities that we all live and work in. We have faculty who are constantly taking this research to new levels with trying to be very innovative and look at solutions, working with the community and trying to work with organizations specifically in the corporate sector at a level that we've never seen before. And so we thank any of you out there who are decision makers helping those opportunities come our way to DePaul. We also are always proud to say that, we have great accolades. Like the Wall Street Journal said, we're one of the best colleges in the US, and that is exciting, and we don't take that lightly. And we earn that every day with the work that we're doing and helping students, whether they're undergrad or graduate students, or even the partnerships, like I said, that we're grateful for those accolades. But really, when it comes down to our mission, what we really are about is creating economic impact and preparing and inspiring individuals to be change agents in the world. And so we are constantly working with industry to look at ways that we can partner with you and help provide that education to our students. So if any of you are out there who have hired our students, thank you for doing that. We appreciate your support. Our team has been working with companies for the last 10 years. And the primary focus of our work was in workforce development. And we really try to make sure that we are there for individuals who want to get upskilled or reskilled for their professional growth, or if they're looking to advance with maybe a degree. Maybe you haven't finished your undergraduate degree yet, or maybe you're looking to even get a doctoral or a master's. We're here to help you do that. But we also are connected to our colleagues in the Career Center, again, for the talent pipeline. We've got our friends and colleagues in corporate training through executive education or in the College of the School of Continuing Professional Studies. We've got ways we can help with customized training. And more, we're still really dialing in on how can we be partners with the community for corporate social responsibility initiatives. And we really value the opportunity to serve you. So when you are facing opportunities to partner, perhaps you'll think of DePaul, and we would really appreciate and be honored to be invited to the table. I talked about our team, and this is the result of our work. We are so thrilled that we can showcase all of you. Each of your organizations had confidence in DePaul and partnering with us. And many of your organizations have a very strong presence here in Chicago, and some of you have very small presence here. But we are very proud of having all of these organizations standing with us. And what it really demonstrates to us is that our students represent all these organizations. So when you are studying at DePaul, you're studying with people from all of these leading companies. You're with really smart, motivated, talented individuals who, like you, want to solve problems and make a difference, whether it's in your own community or within your organization. And so looking at this list of esteemed organizations, we just want to say thank you. And if you've been a part of helping facilitate these opportunities, we're very grateful. Two quick bits here, just in terms of, for those of you who are working at those companies, we want to make sure you are aware of a resource page that we have. We relaunched this last year, and we are seeing a lot of traffic, so we're hoping that means it's been helpful. It's got this QR code will take you to this landing page. So whether you're looking for a solution and wanting to know what DePaul can do to help you as a decision maker for your organization, you can visit this site. If you're an individual looking to find out more about our academic programs and how you yourself can grow, we've got a pathway for you over here for employers. So visit this site if we can help you. And I'll touch on this a little bit. I was telling someone earlier in our office that our goal is to kind of like be your travel agent. We want to help you get to your education as easily as possible. We want to help you find the right programs. We want to help knock down the barriers, make it easy to apply, make it easy to learn about DePaul, and really start to understand why this institution is so special. We offer tuition benefits, certainly. We offer a lot of professional development and access to upskilling and reskilling opportunities. But we're just trying to be very helpful. So if there are things that you think that could be valuable, let us know. We would be happy always to hear more about that. Two upcoming things I want to just highlight. In October, we have a two-part series on change management. And I can't wait to have everyone see this. This will be featuring Professor Grace Lemon. Grace is a fantastic faculty member in our Driehaus College of Business. She's been touching on these subjects. Many of you may have already participated in one of them, but this is designed to be, first, how to lead yourself through change without burning out, And then the second opportunity in October, part 2 of that, is leading others through change. So we hope that you will be part of that, and you can register here. And the next event coming up comes from the College of Business. They've got an exec ed team that's offering a 2-day, it's on campus here in the Loop, leading with presence. So if you're interested in that, we will send information on how to register for that. We can put that in our follow-up to each of you, as we do every time. So let's get on with the show, and let me introduce my colleague. And Bamshad, I'm gonna keep it short because I want to give you as much time as possible, but I want everyone here to know that this is an individual who has been leading in his field for a very long time. But at the same time, I've never seen anyone so interested and constantly looking to keep learning more and sharing that with everyone. He has an esteemed background in his academic career. He's the director of the DePaul AI Institute. He visioned this concept of being an interdisciplinary approach to looking at AI. He knew it was coming. He wanted to make sure that the university and our community at large was ready for it. Machine learning has been his background, and he's published books. He's been in scientific journals. And frankly, he's an incredible gentleman, and he's been a wonderful partner. And I am so thrilled that Bamshad is with us. So Bamshad, I didn't do it right. There's so much more to talk about for you, but I'm going to let your magic speak for yourself. And welcome to the DePaul Speaker Series.
Well, thank you very much, KK. And likewise, I'd like to thank you guys for the incredible collaboration we have had with, I think both the AI Institute and DePaul have benefited from this collaboration. And hopefully the audience here would also benefit from continued collaboration with, particularly with focus on different aspects of AI in the future. And thanks for your introduction. Let me share my screen here.
I'll let you go, and I'll watch the chat, and I'll go off screen. But thank you again, everybody, for joining us, and keep up the good questions, and welcome to everyone. Thrilled to have you here.
Okay. Well, hello, everyone. It's a pleasure to be with you today, and it's a great opportunity for me to talk to you a little bit about AI, and in particular, I think some of you may have attended some of the previous sessions where we covered various aspects of AI, including specific types of applications, including some practical uses of AI or uses of AI in particular domains. Today, I want to look at AI and how it's serving as a catalyst for innovation across industries, and maybe focus on some of the key AI trends that are likely to be the focus of attention for going forward in the next few years. And some of these you've already heard about. But in particular, I'm going to focus part of the talk about what is being referred to as agentic AI, the idea of autonomous intelligent agents that, in combination with other kind of technology, can automate processes. So I will discuss that. I will look at, briefly look at a few kind of case studies where agents are being deployed and how it's affecting overall some of the industries. But I do want to start with a little bit of background about AI, because everybody talks about AI, but often sort of we skip over the fact that AI actually has been around for a very long time. It's in fact a pretty old discipline, which started, even before the days where there were general purpose computers. People had started thinking about machine intelligence. And going back to the times of Turing, for example, Alan Turing, which you may have heard about, who sort of coined the idea of the term machine intelligence, and started talking about what are the potential characteristics of intelligence or consciousness within machines and so on. So this has been a long debate. In fact, AI as a discipline really goes back 70 years or more, 70 plus years. There's been lots of work done by researchers in AI, people like myself in academia, but also in the industry, who have tried to develop systems or models and algorithms that understand or solve challenging problems. They can reason and act as rational agents, similar to humans can, and they can learn from observations or adapt to new conditions or interact with the environment and so on. So, I mean, this has been the goal of AI. And some of you may be familiar with this sort of an idea of artificial general intelligence. So, this is the idea that often gets a lot of headlines, right? Sort of, it's been a grand vision of AI to sort of create, um, all-inclusive sort of machine intelligence, basically creating a general artificial intelligence that, with a hypothetical capability to understand and learn and be able to perform intellectual tasks very similar to a human can. And of course, being machines, probably do it much faster and maybe more effectively. So this idea has been around and it's actually inspired imagination and various kinds of cultural artifacts, and not to mention movies and stories and science fiction and all of those things. So I'm sure people have been talking about intelligent agents and AI more generally in many different contexts. Now, going past this sort of a grand vision, there's actually a more practical vision of AI that's maybe more relevant to what we are seeing today. So, I'd like to use this quote by Jeff Dean, who was the senior fellow at Google that really started Google's initial kind of foray into AI. He said that we want to use AI to augment the abilities of people to enable us to accomplish more and allow us to spend more time in our creative endeavors. So, in other words, the goal of AI is really to build intelligent applications, to automate tasks, and to increase productivity. So this is a bit more practical vision, and actually, this is really the bulk of the work that's been done in AI in practice, particularly in industry and variety of applications, is based on this more practical vision. There are lots of success stories going back long before the time of ChatGPT and large language models. Many applications, including web search, games, predictive analytics, computational biology, e-commerce, robotics, social networks. Many of the tools and applications that we often use on a daily basis, and we have for a long time, have used AI technologies underneath. So if that's the case, then what's new? So why all of a sudden there has been this explosion of interest in AI and this revolution in adaptation of AI technologies across lots of different fields? And to the point that it's really affecting everything that we do and all of our lives in every way. So let's talk about what was the old AI versus what's the new AI. First of all, sometimes people confuse or conflate the term machine learning with artificial intelligence. And machine learning certainly is part of artificial intelligence, but you can think about artificial intelligence as being a much broader field that has many different aspects. Not all of them are necessarily about machines being able to learn. And machine learning, of course, as the name suggests, are the idea of building algorithms or applications that can learn from data from the past, and then be able to, for example, use the models that have been learned or trained from that data to be able to predict the future. So this is the basic notion of machine learning, essentially systems that sort of improve themselves over time, for example, and make predictions and so on. You may have heard of also the phrase deep learning. Deep learning technologies are sort of behind much of the new advances in artificial intelligence. You can think of that as a subset of machine learning. So deep learning is based on models that are based on neural networks, but they have many layers. So fairly complex structures of neural networks that can accomplish fairly complex tasks. So there's been for the past, I would say, 15 years, perhaps 20 years, there's been a lot of work in deep learning, and much of the advances before ChatGPT, before the time of ChatGPT and so on, in image recognition, in for example, speech recognition, things like that, were based on these deep learning models. Now, when we talk about machine learning, most of the time, people think about what's referred to as supervised machine learning. Supervised machine learning are the kinds of basically machine learning models where you have a training data and then you train the model on that data and then you make predictions. For example, you might predict maybe a particular, for example, bank might want to try to determine whether or not to give a loan to customers or not. So you can build a model based on prior customer data, bank customer data, and your knowledge of what may have been the behavior of those customers. And once you have the model, then you can apply that to some new cases and make predictions whether somebody is creditworthy or not, for instance. That would be an example of a classification task, which is a supervised machine learning. Many of you probably have heard about or used idea of regression, like logistic regression, or just building a linear regression model, things like that. Those also kind of fall into this category. Now, these traditional AI models that have been around for many, many years, these kinds of algorithms, what was unique about them is that they're kind of siloed models. That means in order to build, let's say, the bank application that I was describing, you are training that model on very specific data set for that bank, or maybe more generally for bank customers, and then applying it to this data set. So these are task-specific types of training. And there is lots of human supervised involvement in like labeling data, in collecting data and things like that to be able to build these models. And if you want to perform a different task, you have to build a different model using a different data set. So this was really keeping machine learning and more generally AI from going to the next level, right? Being able to be scaled across different applications. And this is where sort of the paradigm shift happened in AI. And those paradigm shift was the advent of what we call foundation models. So foundation models, the idea behind it is that rather than building individual models in specific data sets, in kind of siloed models, you train a very generalized model on any kind of data that you can get your hand on text, images, speech, structured data, maybe signals, all of the text that you can find, let's say, on the internet and everything, right? So not something task specific. So this training gives rise to a pre-trained model. And then you can adapt this pre-trained model or tune it for specific types of tasks downstream. So question answering, classification, object recognition, various kinds of things that we see these models do. So a special case of foundation models are large language models, the kinds of things that we see now with GPT-5, for example, or other kinds of things. In fact, there's a lot of these models, and I'll talk about some of them. So foundation models are pre-trained, what we call self-supervised predictive models. They sort of, once you sort of start training them, they train from all of the data that's available. And usually this data is generalized, multimodal. That means there are different types, could be text, images, video, etc. And typically these models use deep learning architectures called transformers. In fact, transformer architecture, which is part of deep learning technologies, was really the game changer, which led to the creation of things like ChatGPT. We're not going to go into the details of that, but just in case you have heard of this term, in fact, the T in GPT is for transformers. But these models, really what they do underneath is that they predict sequences, word sequences, based on what's been observed before. And whatever observed before could be some kind of a context maybe either before or around that particular word sequence that you're trying to predict. But it's doing it based on lots and lots of data. So to us, it seems almost like magic that it's answering questions. Now, these models are general purpose, but they're unfinished in a sense, right? So they must be tuned to specific downstream tasks. And the reason they're called foundation models is because of their role as sort of a common building block of other kinds of applications. So what you see right now in the industry, the reason there are so many AI applications are popping up, everybody is sort of creating AI apps, is because they are using these pre-trained models as the basis for many of these applications. Then they're creating new apps by tuning them or training them on the small data sets for specific downstream tasks. But the foundation of many of these applications that are being developed are these pre-trained models that are developed by companies like OpenAI, for example, GPT, Meta, Llama, Anthropic, Claude, or Google, for example, Palm, or more recently Gemini, and so on. So many of these pre-trained models are being used as the basis for developing other kinds of applications. From the very start of creation of these foundation models, the promise of these large-scale foundation models was that they could eventually work on multimodal data, not just text. They would be able to deal with very expressive kinds of structures and networks. They could scale the computation because the models are already pre-trained, so you don't have to train them for specific domains. And they have compositional representation in the sense that you could do what's referred to sometimes as transfer learning. You build models that are trained on some data, but you could potentially make predictions in a different domain that the model wasn't trained on. In addition to that, the most recent kinds of advances involve being able to tie in memory and storage and other data sources to be able to continue to further tune the model and make it better and better. This is sometimes called retrieval augmented generation, or RAG. You may have heard of that term. Now, this was sort of the promise, but in fact, foundation models that exist today have achieved many of these promises. So leading models, for example, GPT-5 now, Gemini 2.5, Claude 4.0, these have really cutting-edge AI capabilities, many of which I was just referring to. They support real-time multimodal inputs often, and also multilingual inputs. They handle very large context windows. So rather than just a few words before, a few words around a particular sequence of words that you want to predict, you could give it a whole book, for example, millions of tokens that enable deeper document analysis, for instance. Furthermore, many of these models now, they deliver advanced reasoning capabilities by, for example, being able to break down different steps in the way that they come up with the answer. They integrate enterprise data through RAG that I was just referring to provide context. And also what we are seeing is that basically, many applications used to have, lots of different kinds of user interfaces. Not really the language is basically the user interface for many of these applications. And, this may not be as fancy as, old-style graphical user interfaces, but it actually makes it easier to deploy and use these models because you're really interacting using natural language with these models, like people do with ChatGPT. Okay, so that brings me to, so this is sort of where we have been at, but in the recent couple of years, there's been a lot of focus on what we call agentic AI. And this is the first key trend that I want to sort of talk about. So the idea of these agentic AI is that you want to move from just having assistance where you give it a prompt and then you get a response to actual autonomous agents that are actually performing tasks. You give it a description or you say, do this for me, and they go through some complex sequence of activities and tasks and perform that for you. So that would be an autonomous agent. The idea of agents, by the way, or autonomous agents, has also been around for a very long time. So this is not a new notion, right? And you can think of agents as having some kind of an entity which has sensors, and these sensors allows it to perceive information from the environment, and it has effectors, or sometimes called actuators, that take action on the environment, right? So that's a very generic definition of agents. But of course, different types of algorithms and modeling approaches um, basically determine what kind of an agent design you have. So that idea has been around, and in fact, people have worked on in AI in the various kinds of techniques for autonomous agents for a long time. What's really been the game changer is the combination of this agent architecture with these large language models that we were just talking about. So this combination allows agentic workflows shift from single prompt chats to these compositional LLM pipelines, basically, that allow these agents to perform very complex multi-step tasks. They incorporate autonomous planning, use of tools, for example, such as being able to use a search engine or being able to access a database, or even other kinds of things, maybe send email, those kinds of things. So the agents would be able to, based on the sort of LLM kind of descriptions, be able to actually plan what to do and then use tools to accomplish those tasks. Also, I mentioned these large contexts. This allows planners to reason over outlines, so not just over a single kind of task. And because they have function calling sort of API capability, they turn LLMs essentially into kind of a control program, not just something that gives you a response to a prompt. So there are lots of open frameworks that have been launched in past couple of years, including things like Crew AI, AutoGen, LangChain, LangGraph, and so on. These are open frameworks, so it's allowed many people to try to develop agent technologies. So there's been wide integration across lots of different application domains. Now, when we talk about agents technologies, there is kind of an architecture. So there is kind of a process or the different modules that need to be part of the architecture of these intelligent agents. One is the perception module, which collects and interprets data from sensors, from API, from knowledge bases, etc. Then the second part is the reasoning and planning agents. This is where LLM comes in, and LLM allows to determine optimal actions that are aligned with the specific objectives of the agent. Then there's the action execution layer. Sometimes people refer to this as orchestration layer, which basically interfaces directly with some external systems or other kinds of applications, as I said, like email application or a search engine, etc., to carry out those planned tasks effectively. And then also there is a learning mechanism with these agents that allows it through continuous feedback, be able to analyze and improve sort of its actions over time. And of course, because of LLMs, you have a communication interface that can directly communicate with human beings and potentially even with other agents. Now, the second trend that I wanted to mention is the idea of verticalization. So I mentioned that there is many different large language models that are trained on all sorts of different data, where there are also domain-specific AI agents, like in finance, for example, or healthcare, education, etc., manufacturing, that pair maybe smaller, slim LLMs with proprietary data and this idea of RAG, the retrieval augmented generation, and agentic task automation. The agentic capabilities I was just talking about, and the use of domain-specific kind of models is actually a very powerful combination that's leading to a lot of early adoption and some good success stories across different disciplines. I'll talk about a few of those. But the idea of vertical LLMs is basically that you have, rather than train the model under everything under the sun, you focus on data sources that are related to that particular domain. So let's say, for example, we're talking about the healthcare domain. Maybe you train the model on, let's say, all of the medical publications that you can find. Maybe access to patient data if it's available. Maybe other information, including sensors, maybe wearable sensors, etc. So imagine throwing all of that in and then training a foundation model that's very focused on healthcare. And then you can use that, for example, for downstream tasks that are healthcare related. For instance, being able to answer questions for patients or interface with care providers or develop new medicines, for example, or do drug discovery, those kinds of things. So that combination of verticalization and agent technologies is, I think, driving much of the innovation that's going on right now in the industry. So, in fact, this is why there's been such a surge in investment just in the past couple of years in AI agent startups. So, according to Deloitte, for example, investors have committed approximately $9 to $10 billion to AI agent startups just between 2023 and 2025. And then there are platforms that are being developed or have launched. For example, Google's Agent Space that are available for enterprise customers. And it's a leading platform for developing agents. And many of these platforms, by the way, are the kind of platforms that you can actually create agents by interacting through natural language with these platforms. So you could start describing, say, I want an agent that does X, Y, and Z, and maybe go through several iterations of question and answers with the system, and voila, it pops up, for example, an agent, and then you can, of course, test it and modify it and so on. Microsoft, Amazon, AWS, they also are launching their own versions of these kinds of platforms. And there are even consumer-grade kinds of version of this. So for example, Microsoft Copilot Studio, you can use that. Some of you may have some experience with Microsoft Copilot. So Copilot Studio allows you to, for example, build rudimentary types of agents. Now, agentic AI market, according to one study at least, is supposed to grow dramatically by 2034 to as much as like $200 billion. And there are other kinds of reports that suggest that it may be even greater than that. I want to talk about a couple of specific case studies. I want to start with one specific company. There are, of course, many of these. So we don't have time to go through these, but so I wanted to highlight one, and that's Walmart, because they have actually done a lot of innovation using AI in recent years, particularly using agentic AI. One of those areas, excuse me, is being able to scale their proprietary generative AIs to really deliver hyper-personalized shopping experience. The idea of personalization has been around for a long time. So having recommender systems, for example, or applications that, for example, understand your profile and then maybe give you some personalized content or maybe recommendations that are tailored to your interests or needs. But with the advent of LLMs and its combination with agentic AI, companies are able to do sort of hyper-personalized kind of develop hyper-personalized kind of experiences in the sense that you're taking into account lots of different characteristics of users and also different types of items. And in fact, you can give personalized recommendation across different kind of domains. So I don't know, maybe you're buying a towel in Walmart, and based on that and some other shopping behavior you have had, maybe you can predict what you might be interested in the furniture category or something along those lines. Also, AI is being used by Walmart in other areas, such as optimizing inventory and pricing, for example, being able to automate agentic replenishment and do real-time demand sensing um, uh, as part of the store operations. And based on the company reports, they are using various kinds of performance improvements, metrics such as tracking things like stock out rates, basket sizes when people are doing online shopping, promotional lift, markdown reductions, etc. So many of these innovations are directly enhancing revenue growth and strengthening customer loyalty, and other companies are sort of jumping on the bandwagon and doing similar things. Let me zoom out a little bit now and talk about um, not just a specific company, but sector case studies. I want to highlight a few sectors. There are, of course, many different sectors that agentic AI is not being deployed in various ways, including manufacturing, for example, things like that. But I want to talk about a few cases that uh, have used AI for a long time, and now agentic AI is really taking automation to a new level. And one sector is fintech, where there is a lot of work being done on AI. Of course, many of us have heard about algorithmic trading that's been going on for a long time, but now agents can actually perform this in much more effectively, take into account lots of different kinds of factors such as market fluctuations, different kinds of technologies, and so on. And this has partly been responsible for the success of a few different funds that where automatic agents are actually consistently beating many of the larger non-automated funds. So other areas in fintech, detecting fraud in real time without manual oversight, where agents monitor kind of transaction patterns and continuously identify anomalies, analyzing complex data for dynamic risk assessment, um, and also areas, for example, such as rebalancing portfolios based on various kinds of signals, including both on the user side, but also on the market side, various kinds of trends, for example. Another sector where we see a lot of adoption of agentic AI technologies is healthcare. So everything from autonomous diagnostic agents analyzing medical data, for example. IBM Watson Health, for instance, has been focused on this, and it autonomously examines medical images, patient records, etc., to suggest diagnoses. But it doesn't stop there. For example, agentic AI now enables personalized treatment plans for patients. Um, it allows for continuous remote patient monitoring with AI based on, for example, wearable devices or sensors, alerting clinicians or even the patients themselves. Um, and also, one area that's, of course, we have seen a lot of success is accelerating drug discovery processes. And in fact, AI has, you could argue, won a couple of Nobel prizes in recent years. One last sector that I want to talk about briefly is customer service. And this is one area where many of us probably are encountering the use of agentic AI and deployment of these technologies. Now, many of you probably have seen chatbots, companies deploying customer service. Uh, many companies, it's very hard now to actually talk to a real human being. And unfortunately, until recently, many of these chatbots have not been very effective, right? So lots of people complain about their interactions. But this is changing because of this agentic AI technologies. Um, it may not have changed completely yet, but we are seeing now much more effective virtual assistants, uh, For example, there's platforms like Google Duplex that help to autonomously handle intricate tasks, including like booking appointments, enhancing efficiency and user experience, and so on. Also, these agents can deliver more proactive customer support, so they could actually predict what the user might need and anticipate those needs, and then be able to, for example, help with actions that the user might need. Sometimes the users don't know what they want exactly, and being able to proactively determine that or predict that and provide solutions is very useful. And coordinating across multiple channels, for example, from email to voice to the web and so on, and personalized responses and recommendations. So personalization really is one of the killer apps of AI technologies. And we are now seeing much more of the ability of these agents to be able to much more effectively personalize interactions with users based on their preferences and needs and of course capabilities. So I want to end with not completely end here, but I do want to say a little bit about managing risk, because all of this so far has been, let's see how great AI is and look where we are going with AI. And all of that is perhaps true. But one thing that should not be left out is that there are some serious risks with using AI technologies as they become more and more powerful. And it is important to have some key strategies to mitigate AI risk as organizations try to build on these capabilities and deploy them. Unfortunately, many organizations are not really following through with these, and at least in the United States, we do not have the regulatory mechanisms right now to try to ensure that this is happening. But what are some of these key strategies? And some companies are trying to be good about, to the extent possible, doing this. One is, of course, transparency and explainability. This is a serious problem with many of these AI models. Because they're based on these deep learning kind of architectures, they're kind of black boxes. Even ChatGPT and all of those LLMs that we tend to use, you don't necessarily know how they're coming up with the answers. Even the people who design these and develop these models, they don't necessarily know exactly. And this gets worse when you're talking about agentic AI, because you're not just talking about a one-step process, but complex tasks that are being done in sequence, and each one of those is in and of itself is a black box. So it's important to try to build in ways of being able to create transparency, explain, for example, what is the rationale for autonomous decisions that are being made by these agents, and so on. Another important area, of course, safety and reliability, to make sure that, particularly dealing with uncertain kind of environments, that you prevent failures and enhance stability of these models. One very key area, and this is an important not just for agentic AI, but generally in AI when you're trying to build models, is mitigating bias and promoting fairness. You probably have heard and know about stories where because these models are being trained on some data, if there are biases already in the data, those biases are going to propagate to the decisions that are made, or maybe the answers that are given by these models. So carefully curating the data sets, or even actually working on algorithms that take fairness and mitigation of bias into account as part of the design of the system is a very important area of work, and it's important for organizations to take that into account. Protecting data privacy, of course, is a key aspect that is important to discuss, particularly when you're talking about domains where there's potentially sensitive data, like healthcare, for example, or even finance, etc., where the potential risks are great. It is particularly important to protect data privacy. And finally, the issue of accountability. So there needs to be established legal and ethical guidelines and frameworks that address, who's accountable for the decisions. If agents, for example, take certain kinds of actions, we need to make sure that there is kind of a responsibility attached to those things, and there's someone to answer for them. And accountability, of course, is a key aspect of being able to develop trust, right? Both organizationally within the organization, but also for the end users and end customers. Now, we did not get into these ethical principles and ethical responsibility issues. If you're interested in that, we're going to have another session in November where the focus is going to be not more on the trends, for example, and different type of technologies, but actually on ethical frameworks. So we will discuss that. Hopefully, you can join us for that session as well in November. Let me just end with a little bit about the Paul AI Institute. KK mentioned the Institute and our collaboration to develop these programs, but the AI Institute was developed last year. You can find out more by going to aiinstitute.depal.edu, AI Institute, one word. And the goal of the AI Institute, it was developed to support interdisciplinary research and educational programs centered around the promises and challenges presented by AI. So not just education about AI, but also education and research about applications of AI in different domains and implications of AI, including ethical and social implications of AI. So that is one area of emphasis, and interdisciplinary work across different disciplines is, of course, another area of emphasis of the AI Institute. AI Institute also wants to develop partnerships with industry and nonprofit organizations to address different societal, ethical, and environmental challenges posed or mitigated by AI, and act as a resource, particularly within DePaul, but in the longer term, maybe outside of DePaul as well, as a kind of an educational hub on AI and its applications for faculty, students, and maybe for people outside of the university, including people in various organizations or companies that are partnering with us. We are going to be developing a industry advisory board. If you're interested in the AI Institute and you want to find out more, please feel free to go to the website, reach out to KK or reach out to me directly, and I'll be happy to discuss that with you. Okay, I'm going to stop here and see if you have any questions.
Bamshad, thank you. There have been some questions in the chat. First question was just, in terms of feeling like there's people worried about being replaced. Are we going to replace writers and editors and how do we, so there was that question. And then there were a couple questions just about legal frameworks and what are going to be the laws and the policies that are going to govern this. So you mentioned November session, and eliminating risk and bias with information. So go back to the first question, because I think that's the question a lot of people are wondering is my job vulnerable? Is the work I'm doing vulnerable?
Yeah. Well, it's hard to say that certain kinds of jobs are not vulnerable. We are already seeing the impact of that, right? I think this is more generally a function of automation than it is a function of AI in particular. So there have been others times where technological advancement through automation has led to these kinds of changes in the job market. And yes, there are certain kinds of jobs that might disappear or change dramatically. I would say that we are seeing a lot of different ways that some of these kinds of jobs have changed.
Mm-hmm.
So people are starting to use AI as a tool to do those kinds of jobs rather than maybe doing it from scratch, right? But the type of jobs don't necessarily go away, right? The nature of how people do those kinds of things change. A good example of it is programming or coding, right? So being a computer scientist and teaching sometimes programming courses, the way that we have taught programming for a long time has been to try to teach the syntax of a particular language, maybe Python, maybe Java, etc. Then, have some beginning level courses where people start learning how to put the, basic kinds of code together, sentences together, and so on. Now, that level of low-level coding is no longer really seems to be necessary because AI actually does a much better job coding than most students that I know for those kinds of things. So, on the one hand, low-level programming positions may be going away. On the other hand, by using AI tools, people who would sit for hours and deal with syntax errors and things like that now actually can do bigger things by having the AI tool do the low-level coding, and maybe they think about more bigger problems where you need to combine different components and so on. So that's just an example, but I think we are going to see obviously lots of changes in different industries in the way that people do their
Yeah,
jobs.
I wish we had time for people to weigh in and just tell us, how have they been using it in their organizations? How are they governed by their organization on what they can and can't do? Particularly to the person who asked just about making sure that, that they're using it in a way that's helpful and it's, valid, and you don't have to go back and double check it. Like every industry and every sector is kind of creating new rules that didn't exist 2 years ago. So it's fascinating to see how it's moving so quickly. Everybody, there's a poll that's still open, just asking for feedback on how you thought today's session was. Bamshad, I am excited for that November session to really talk about some of the ethical challenges and things that folks should be considering.
I think
As
that's a really important
yes,
this equation, and I think that there was a couple of, or at least one question that was talking about this. That right now, the all of the sort of the incentive structure is for companies to really try to develop these technologies as quickly as possible and put them into the market. And often this is being done without a lot of guardrails, without a lot of ethical standards. So there's a potential for harm, for example, that's not being analyzed or evaluated in all cases by companies. So it is important to try to develop ethical guidelines, which are either voluntarily or, in my view, preferably through regulation, um, uh, sort of govern this space. Now, in outside of the U.S., there's a lot more of this kind of regulation and that's called frameworks in place. For example, the EU AI Act, is pretty comprehensive. But there are also the other sort of side of the coin because uh, companies in Europe now are complaining that maybe is stifling innovation and that they can't compete, for example, with excuse me, with the U.S. industry. And that's partly also true. So I think that the trick is going to be to find the right kind of balance to make sure that the most egregious kinds of harms that could happen because of the irresponsible deployment and development of AI technologies are mitigated, but at the same time, you have enough support for developing the kind of applications that can help different aspects of society improve.
yeah. I know we're over the hour and people have to hop to their meetings. Bamshad, thank you so much for taking time and showing us the historical insights, how it's evolving, the problems that it's been able to solve. Thanks for the kind notes and the applauses and the hearts. Look at that. Look at that, Bamshad. There's all kinds of applause here. So thank you, everybody, for taking time and being a part of this. We hope you'll come in. Join us in October for the two-part series with Dr. Grace Lemon on change management. Another very interesting and engaging topic. Again, we'll send out a link, Bamshad, to the AI Institute site with the recording. We will send slides to everyone who's been attended, and just have a great afternoon and know that DePaul thanks you and appreciates your commitment. Bamshad, thanks a million. It's been great
Thank you
working
very
with
much.
you on this.
Thanks for attending, and it was
Yeah.
a pleasure to talk to you today.
Wonderful. Thanks, everybody. Have a nice afternoon and go Cubs go.